freely falling bodies. What do I mean by this? Freely falling bodies. Even though I have used the word falling, I mean freely kept bodies in the space. So I have a body freely falling. I left it. I just left it. Or I have projected it up. I mean just projected it up. Okay, when the body is freely in the space, what's the meaning of my freely falling bodies is I kept the body freely in the space. Either I have dropped it or I have projected it up. Right? When the body is freely in space, what happens when the body is freely in space? See, I'm holding it now. Let us say I have not hold it. It is in space. At the moment it is in space. What are the forces acting on it? Forget there is air and all. I'm not taking air resistance, nothing. Just it's in vacuum. It's vacuum. Now on the surface of Earth, there's no air, nothing. There's no air drag. Freely on it. Now what are the forces acting on it? There's only one force, that is the attraction force due to the Earth. That is the gravitational force, attraction force, gravitational attraction by the Earth. And how much is that force? That is nothing but how much? mg. Now, so I'm just using the Newton's formula, but I will derive it and explain you very clearly. What is the Newton's formula? F equal to ma. If the only force acting on it is the gravitational force, that is the mg, its own mass into g, that is nothing but equal to ma, mass gone. What's the acceleration left out? G. In which direction? The Earth is pulling it downwards towards its center. It will be towards the center. Now please all of you see here. This is my ground. I have some object, just a ball I have taken. It's free in space. It's freely in space. Now the only force acting on this body is the attractional force. The Earth is attracting it. Come down. With what force? Let us say the mass of this ball is m with mg. From Newton's second law, F equal to ma, what I can say, mass will go, and the ball will have a net acceleration. The ball will have a net acceleration in the downward direction. That is nothing but equal to z. Why I'm not interested about this mg and all this? Now I'm not dealing with what is the cause of motion. I'm only interested in how the motion is going to happen. Now, after some more time, when we go to the third unit, fourth unit, I will take mg everything and do the problem. For the time being, whenever the body is in space, either going up, coming down, going in a curved path, I don't know, as long as it is freely in space, I'm holding it here, sir. If I'm not holding, just think I'm not holding, it is in space, The only what this motion variable it is having is acceleration due to gravity g downwards. So acceleration to gravity g downwards, and what's the value? 9.81 meter per second square. It will be varying from place to place. At sea level, it is a value 9.81 meter per second square, vertically downwards. All of you are okay with this? Now let us proceed. Going up. What do I mean by going up? Ascent. When the body is going up, when the body will go up, if I with some initial velocity, I have projected up with some initial velocity u, I have projected up with some initial velocity u, it will start going upwards. It will start going upwards. This is my Earth. I have projected an object with some initial velocity u. It started going up. Right? Now, how is the acceleration created by the Earth? Whether you go up, come down, go side, nothing matters for me. As long as you are in space, as long as you are going in space, I cannot have it continuously going. As long as it is in space, the only acceleration created by the Earth is g vertically downwards. Now, is this g going to increase my velocity or decrease my velocity? Is it going to increase the velocity or decrease the velocity? Both are not in the same direction. If the velocity and acceleration both are in the same direction, it will increase the velocity, acceleration. But it is in the opposite direction, so it is going to retard the body. So I will take it as minus g. I'll take the acceleration as how much? Minus g. Now, coming for the other case. What's the other case? If the body is coming down, descent. Now what happens? See, if the body is having a velocity downwards, it's coming down, right? It's coming down. Now, if the velocity is downwards, what will happen? Earth is not going to change its opinions. Whether you go up, come down, whatever you do, it is going to pull you down. It is only going to pull you down, right? So, What's that? Acceleration g is acting downwards. Now, because of this g, is the velocity going to increase or decrease? Obviously, both are in the same direction. It is going to increase. So, as both are in the same direction, I'll take it as plus g. Plus g. Are you okay? So, when the body is going down, it is going to retard the body, minus g. When the body is coming down, it is going to accelerate the body. So, it is plus g. Now, what's the value of g already given? 9.81 meter per second square. Now, is it a function of time, velocity, distance? Is it function of anything? Nothing. It's a constant. As it is a constant, as long as my acceleration is constant, can I use the formula v equal to u plus at, s equal to ut plus half at square, and v square minus u square equal to 2as? Yes or no? No doubt I can use them. But I have a small problem. What is that small problem is, if suppose I have projected an object, like this, it will go up and then come down. The problem what I have is, while going up the acceleration is negative, while coming down it is positive. Now, still I can take the common origin and solve the problem, but it will become a bit complicated for me. So I'm splitting the problem into two cases, ascent, descent. So while going up, I'm taking it as minus g, 9.81. While coming down, I'm taking it as plus g, plus 9.81. Can't I do while taking with the same reference and do it, sir? Yes, sir. But it will become difficult. Always the values will come from the base. You cannot visualize it properly. So I'm separating the cases and I'm calling it as, while going up it is minus 9.81, while coming down it is plus 9.81. So what will happen to my formulas? So V equal to U plus AT minus G in place of A. S equal to UT plus half AT square. So acceleration is minus G. V square minus U square equal to 2AS in place of A minus S. H. Same way there also. That is plus G. A is just replaced with G. V equal to U plus GT. S equal to UT plus half GT square. V square minus U square equal to 2AS. That is 2GH. Right? Now, what's that? From where this height H need to be measured. See, for this case, it is starting from here. And the initial velocity here is u, and the height h here is 0. Now, what's the meaning of that height h? From this point, the height is going to be h. But for this, it's not from the ground. The h is not from the ground. From where? It is starting here. The initial velocity is from here. Now, the h is from there. The h is from that point. Okay, you can take this as base, you can write this as minus h, minus u, all these things and solve the problem, but it will become a bit complicated for us. So I'm splitting into two cases, ascent, descent. Whenever there is a problem in the vertical direction, split it into ascent, descent. Okay, when it is a freely falling case, whenever the object is in space, split it into two, ascent, descent. So ascent, this is the starting point. For descent, this is the starting point, right? Initial velocity is in this direction, so take the displacement in this direction as positive. As acceleration is also in the same direction, positive. Here acceleration is in opposite direction, negative. U and H are in the same direction. Okay, so whenever there is a problem, the best direction which we can take is the velocity direction as positive. Don't take velocity direction as negative and get confused. Always I will take in the problems, my velocity direction is positive, so obviously displacement will be in the velocity direction, so that is also positive. Just check the acceleration. If it is in velocity direction positive, opposite direction negative. Here in the opposite direction negative, there in the same direction positive. And from wherever the body starts, take that as a starting point origin. For this case here, for this case here. All of you okay with this? So we have a problem. So this problem I have kept for explaining the theory. So that's why again I started with the number 1. So don't get confused. Roman 1 I have given. So let us solve this problem theoretically first. Then I'll substitute the values and get the things. Please listen to this very carefully. I am not going to explain in projectile motion very detail how the derivations has come. Here I am going to do that. So please listen to this very carefully. First read out the problem. A ball is projected vertically upwards. With an initial velocity of 50 meter per second. Find number 1. Maximum height reached. Number 2. Time taken to reach the maximum height. Number 3. Time taken to reach the ground back. Number 4. Velocity with which the ball is going to hit the ground back. Number 5. Velocity at half the maximum height. Okay, shall we start? Just I'm having a case where a ball is projected vertically upwards with an initial velocity of 50 meters per second. This is the only data given. The initial velocity is 50 projected vertically upwards. That means I have a ball on the ground like this. I have projected it up with an initial velocity u. Value I'll substitute later. Okay. Now I need to find what is the maximum height it has gone and how much time it has taken to go to that maximum height, and from there how much time it has taken to come back. Now while coming back, with what velocity it is going to hit the ground back, and finally at half of the maximum height, what is the velocity going to be. Okay, all of you, shall we start? Please, all of you, see here. Listen to me carefully, sir. You can copy later. Listen. This is my ground. This is my ground. Initially the ball is here. And the velocity is how much? Some u. It has given an initial velocity u. Now tell me, sir, what happens if the ball is projected up with an initial velocity u? Exactly at the instant I projected, even before the instant I have projected, after the instant I have projected, while I am projecting it, every time the earth is pulling it down, and it has always acting a force on it mg down, so it has an acceleration g, acceleration due to gravity g, always acting downwards. So I have an acceleration a equal to g, which is acting downwards. Now it is plus g or minus g. Both are not in the same direction. It is in the opposite direction. So minus g. That means I have projected up with u. Earth is pulling it down. Come down. It's pulling it down. So what happens because of that? As it goes up and up, the velocity will decrease. Finally, after reaching some height here, what will happen? You remember the problem which I have done when it is having an initial velocity 2 meters per second and a retardation of 0.1 meter per second square minus 0.1. What happened? It went. It turned back. Same way it will go. At some point, finally the velocity will become zero. But still, what is happening? The earth is pulling it down with an acceleration of minus g downwards. The earth is still pulling it down with an acceleration of minus g downwards. But after here, as it is still pulling it down, after getting this velocity 0, it will start coming down. So till here the body is going up, and I call this as ascent. First, let us finish this case. Now we'll go for the second case. Okay. Now what happened? At time t equal to 0, the particle is here with an initial velocity u. As it is going up, it has a retardation minus g, so it slowed down. Finally, it became 0. Now, I want to find this height. This is nothing but my what height? Maximum height. This is nothing but what? My maximum height, right? So, first one. Please all of you see here, while the body is going up, that is ascent. What is happening? Initial velocity is u. Final velocity v is 0. Acceleration is in the opposite direction of initial velocity, so minus g. And what is the distance it has traveled by the time the velocity becomes 0? H max, that is the maximum height. Beyond that it cannot go because the velocity has become 0 there, right? Now I have all the 4, but there is no time. So whenever there is no time, what's the best formula? V square minus u square equal to 2as. Final velocity is 0, initial velocity is u, 2, acceleration is minus g, s, h max, minus gone. Finally, my h max, the maximum height reached, is u square by 2g. So the maximum height reached is h max is equal to u square by 2g. First question I got. Second, what is he asking? Time taken to reach the maximum height. So from which formula I can get? Any of those two, v equal to u plus 80, s equal to u plus half 80 square. It is simple to use the first formula. What is that? V equal to u plus 80. V equal to u plus 80. From that, what I can write? Final velocity is 0, initial velocity is u, acceleration is minus g, and t. What is the t? The time taken to go from the lowest point to the highest point, that is during ascent, and I call it as time of ascent, TA. Time of ascent, TA. The time taken to go to the maximum height, t equal to time of ascent, TA. So how much is that going to be? Send it this side. So time of ascent, TA is equal to u by g. So time of ascent, TA is equal to how much? U by g. Right? So what are the two formulas I got? The maximum height reached h max is equal to how much? U square by g. I'm sorry, u square by 2g. And the time taken to go to that maximum height is how much? U by g. Are you okay with all these things? Next. So you asked the first one, was that time taken? Sorry, maximum height reached. Next, second one. Time taken to reach the maximum height. Next, third question. Time taken to reach the ground back. Time taken to reach the ground back. When it happened? It happened during descent, right? Descent, right? Now, please see here, all of you. So, now it started coming down. Here it is going up. So, I told ascent. Now it started coming down. So that is nothing but what? Descent. It is nothing but what? Descent, right? During descent, right? So now this is the start. Here, for ascent, this is the starting point. This is the end point. For this, this is the start. And this is going to be the end. So at the starting now, what is going to be the velocity? What is going to be the velocity? Remember carefully, in the previous problem I explained, whenever it is exhibiting the continuous motion, the end of this will become the start of this. What's the final velocity here? 0. It will become initial velocity. It will become initial velocity. So at the maximum height, the velocity is 0. 0. Now what happened? Now the velocity is 0. Now it started coming down, coming down, coming down, coming down. Why it started coming down? Because Earth is pulling it down with an acceleration g. Now it is coming down, acceleration is also down, velocity is also going to increase in the same direction. So it is plus g or minus g? It is plus g. Acceleration is plus g. It started coming down. Okay. So here time is 0. By the time it reaches here, let us say the time of descent is td. The time of descent is td. Now I have to find this. Tell me how to get it. How to get it. We'll go for the descent case. What is the data I know? Initial velocity is 0. Very good. Next. Acceleration is plus g. Very good. What is the final velocity? That is the next question he is asking. With what velocity is going to hit back? I don't know. Next. What's the distance traveled? What's the distance traveled? What's the distance traveled? So it has gone from here to here by a distance of h max. How much it will come down? If you go 10 up, will you go 200 down? Or will you come 5 and stop? So never it will come here and stop and say, yeah, done. It will definitely come back. So whatever it has gone up, it will come the same amount down. Are yes, sir? No, this is the same distance it has traveled, h max. It's the same distance, h max, right? So S is equal to h max, which is nothing but we have derived already, u square by 2g. U square by 2g. Now he is asking time taken to reach the ground back. What's the best formula? That is nothing but t equal to td. So yes, I have t I want. ut plus half at square. It has traveled a distance of how much? H max. That is h max. That is how much? U square by 2g is equal to ut. What's the initial velocity? So for the next case, while coming down, descent, initial velocity is 0 plus half. Acceleration is, now it is not minus g, it is plus g. Both are in the same direction into time taken, time of descent, td square. So what I can say, u square by 2g plus, sorry, equal to g by 2 into td square. 2, 2. So if I send g this side, u square by g square equal to td square. So finally, what is td? U by g. Please all of you listen to me here. Please all of you listen to me here. Previously I got one thing, that is time of ascent. What do you mean by time of ascent? Time taken to travel from the ground to the maximum height. Time taken to reach the maximum height. Time of ascent, that is how much? U by g. Now, what is the time of descent also coming? What's the time of descent also coming? Time of descent is also the same u by g. That means time of ascent is nothing but, time of descent is nothing but equal to time of ascent. Time of ascent. Therefore, time of ascent is equal to time of descent is equal to u by g. So whatever the time it has taken to go up, it has taken the same time. Whatever the time it has taken to go up, it has taken the same time to come down. Now, what is the total time? What's the total time in the sense? From starting, from projection to go up and again come down. To go up and again come down. Nothing but time of ascent plus time of descent. And that is nothing but called as time of flight. That is nothing but called as time of flight. So, LIGHT, time of flight. That is how much? 2u by g. U by g plus u by g. Time of ascent plus time of descent. That is 2u by g. All of you are okay? So what's that? When I project a ball with an initial velocity u, any object with an initial velocity u, it will go to a maximum height of u square by 2g. The time taken to reach the maximum height, time of ascent, is u by g. In the same amount of time it will come back, that is again u by g, time of descent, and the total time of flight is 2u by g. Next. First question, maximum height reached. Time taken to go for the maximum height. Time taken to come back to the ground. Next. With what velocity will it hit the ground back? Listen to me carefully. With what velocity it is going to hit the ground back? That is the final velocity. That is the final velocity. So with what velocity it will come back and hit the ground? With what velocity it is going to come back and hit the ground? He is asking this. Shall we do? So what's the best formula again? So let us go with V equal to U plus AT. For the descent case, I'm talking about which case? Descent case. What's the initial velocity while descent? 0. Yes or no? While starting it is 0 in the highest point. What is the acceleration? Plus g. And how much time it has taken to reach to, how much time it has taken to start from here and hit the ground? What's the time taken? That is nothing but time of descent. How much is the time of descent? U by g. Now, see the beauty here. G call. So what's the final velocity it is going to come and hit the ground? What's the final velocity with which it is going to hit the ground back? The final velocity with which it is going to hit the ground back is the same u. The same u. What's the meaning of this? What's the meaning of this? I'll give you a small example. No need of this much to get it. Take a cork ball. Take a cork ball, project it up, and keep the hand. It will come back and hit you. Very light. You project it like this. Gently. You project it gently like this. It will come and hit it. Now take it, project it a bit high and cap it. Project it a bit high and try to get it. Okay. Now take it, project it as high as possible, and now keep the hand. Project it as high as possible, and now keep the hand. Now what will happen? Immediately you have to call 108. Why? If you keep like this, the ball will come and hit your hands and they will get injured. So if you see the cricket matches, how they are going to take, well, taking it, they will hold like this and they will pull it back. They will hold it and pull it back. Why they are doing it? Unless you are not trained, you cannot take it. Why? Because it is coming with very high velocity. Why it is coming with very high velocity? I projected it with very high velocity. It has gone to very high height and came back also with the same velocity. I projected it lightly. It came and hit back lightly. Right? So if you project it with 10, it will come and hit with 10. Project it with 100, it will come and hit with 100. If you project it with 5. So whatever velocity you project, it will come and hit also back with the same velocity. If you want to take something in your home and try it, whatever speed you project it, it will come also hit with back with also same speed. Okay? So we got the 4 questions. What's that? Maximum height reached, time taken to reach the maximum height, time taken to come back and hit the ground, the velocity with which it is going to hit the ground back. The last question. What's the last question? Read it. Velocity at half the maximum height. Velocity at half maximum height. I don't have more colors. Velocity at half the maximum height, that is at h max by 2. H max by 2. Now tell me, when the ball is at maximum height, see, while going up it is at h max by 2, and while coming down also it is at h max by 2. And he didn't mention when he is asking, so I will do both the cases, while going up, while coming down. All of you okay? Now please listen. While going up, that is during ascent. While going up, that is during ascent. What is happening during ascent? While going up, please see here, all of you. What's the initial velocity while going up? U. What's the acceleration? Minus g. I want the final velocity after it has traveled half the maximum height. Half the maximum height. That is h dash is equal to h max by 2. What is h max, sir? U square by 2g. So it will become u square by 4g. Now I want this. There is no time. So what's the best formula? V square minus u square equal to 2as. Final velocity, let us say v dash, initially u, to acceleration minus g, height u square by 4g. Has traveled distance of u square by 4g, right? Now please all of you see here. G, 2 1s are 2 2s are. What I'm left with? V dash square is equal to minus u square, send it that side, plus u square minus u square by 2. What is u square by 2 minus u square? Sorry, u square minus u square by 2. U square by 2. Send v square that side. V dash is equal to u by root 2. While ascent, while it is going up, the velocity at this point, right, is going up. The velocity at this point is how much? V dash is equal to u by root 2. I need to find what is the velocity while coming down. Okay. Now please again see here. During descent. What happens during descent? What is the initial velocity during descent? Initially it is at, yes or no, at the maximum height. Descent, what is the starting point at the maximum height? 0. What's the acceleration? Plus g. I want to find v dash, final velocity. Now what is the height? What is the distance it has traveled? Sir, see here carefully. If this is half h max by 2, how much this will also be? The same h max by 2 or not? So it is also traveling the same h max by 2, that is u square by 4g. Either from the bottom or top, it is the same u square by 4g. Now again substitute in the same formula. V square minus u square equal to 2as. V dash square minus 0 equal to 2g u square by 4g. Again 2g 4g. 0 gone. V dash square equal to u square by 2. Finally v dash is how much? U by root 2. What's the meaning of this? Going up and coming down. While going up and coming down, at both the times it is having a velocity of u by root 2. Listen here all of you. Instead of keeping the ground here, shift it. Shift it here. Now project it to u by root 2. Project it with u by root 2. Now with what velocity it is going to come and hit it back? When I projected with u, it came and hit with u. Now if the ground is here, let us say I place the ground here. If I project it with u by root 2, it will also come and hit back at u by root 2. Are you getting me? So not only here, you take at any point here. Project with velocity, it will come and hit with the same. You take here, at any point, the velocity is going to be same. Everywhere, same. So I'll do one thing. See here. So this is ascent. This is descent. So I have projected initially with the initial velocity. It has gone to this point and came back. Right? I'm taking at some instances in between. Please, all of you, see here. See, I projected it up with some initial velocity u. It will come and hit the ground back also with the same velocity u. Let us say this is my h max. This is my h max by 2. This is my half the height, h max by 2. What's the velocity at this point? We have derived it right now. What is that? u by root 2. So root 2 is 1.414, greater than 1, so it will be less. So less than this, u by root 2. What will be the velocity here? At the same point, it is also u by root 2. So here it is u, decreasing, and it came to u by root 2. That means in between, it will be having something greater than this u, less than u by root 2. Greater than u, less than u by root 2. And what will be here? The same side. If this is some, let us say some u dash, it will also be the same u dash. Decrease. Further decrease. Here also it will be the same. You take almost here, let us say the ball here, a very slight velocity, a very slight velocity. Here it became 0. That means what is happening? The velocity is decreasing, 0, increasing. Finally, it has reached the same u. And at any height you take, while going up or coming down, it will have the same velocity, but in opposite direction. While going ascent upwards, while coming down, that is descent downwards. All of you are okay? We have not done the problem now. Let us finish that. What is given? It has been projected with an initial velocity of 50 meters per second. Am I right? So it has been projected with an initial velocity of 50 meters per second. He is asking, first one, what is the first one? Maximum height reached, h max, u square by 2g. Let us take z as 10, 50 square by 2 into 10. How much is that going to be? You are not there to help me out. 4 1s are 2, 10 10 gone 5, 2 1s are 2, 25, so 25 into 5, 125 meters. The second one, time taken to reach the maximum height, that is time of ascent, u by g, 50 by 10, 5 seconds. Time of descent, time of ascent is nothing but equal to time of descent, that is equal to, yes, he asked what's the time taken to reach the ground back, that is 5 seconds. If it is total flight, time of ascent plus time of descent, 10 seconds. Next, with what velocity it is going to come and hit the ground back? With the same velocity with which you have projected, 50 meters per second. Next, last question, what's the velocity at half the maximum height, that is some u dash is equal to u by root 2, that is 50 by root 2. Okay, hope you have gained some knowledge from my lecture. If you feel so, please subscribe to the channel. Please leave your valuable feedback and doubts in the comment section. For my complete video lecture series, enroll in OCTEMY. Thank you. Let's catch you soon in OCTEMY. Have a good day.